Hello, dear students. Good morning. How are you all? I hope all are doing great and happy and attending the classes regularly and following the concepts properly. So, once again, welcome back to today's chemistry session and day 9 of our bridge course. So, as I already told you, bridge course is going to be very helpful for your future classes. So when you wanted to prepare for any competitive examination, you need the basic foundation in a proper manner. If you have solid foundation, then whatever you are going to construct on the foundation, it would be so strong. So people who are very strong in their basics can learn properly any kind of concept or any kind of difficult concept. There won't be any difficult concept in your future journey. So with this, I wanted to start today's session. I hope all are doing great and happy, enjoying the classes and enjoying the life properly. Happy? So I'm very happy to interact with you guys on daily basis. So I'm very happy to interact with you guys in online classes. In future, very soon we are going to meet even for offline classes also. So I'm very excited to see you all of guys and take the classes even offline too. Shall we start the class today? Shall we start the session for today's class? In last class, we have introduced mole concept. So before that, we have discussed many important definitions related to mole concept. In last class, I have given two formulas to find out the number of moles. The first one is calculation of moles when the mass of a substance is given. And the second formula is the calculation of number of moles when the number of particles is given. I hope all are listening the class properly. Dear students, I wanted to give a few guidelines. Right. If you wanted to achieve something in your life, you must be very serious in a few things. In terms of when you are taking the class, if you are taking the class with your utmost concentration, whether it is offline or online, it all depends on your dedication. If you are dedicated for studies, no one can disturb your studies. Fine. So if you are sincerely listening, if you are sincerely studying, you can easily reach your destination, the goal which you are aiming to. So as we are preparing for like NEET examination, as a NEET aspirant, as you know very well, every year more than 20 lakh students were writing the examination or taking the examination. So out of 20 lakh students, you know how many people are seriously preparing for the exam. So if you are one of such candidate who are sincerely and seriously preparing for NEET examination, obviously you will see a better result. You will get a good rank and you will definitely achieve your goal. And many people used to like aim for aims Delhi. So if you are focusing really from the day one onwards, not in the beginning of the first year when you join here. So you some people may think like let's see once after going to the college, but I don't suggest in that way. When you are taking the online classes, if you are properly attending the online classes, these online classes, I mean the bridge course which we have started, would be very helpful to you. So it is a kind of strong foundation for the upcoming journey which you are going to start for your 2 years. So without further delay, so I wanted to start today's session. As I have given the two important formula for calculation of number of moles, the third one I am going to add up now. So before going to give the third definition, I wanted to define molar volume. I have defined molar mass in last class. Today we will be talking about molar volume. Can anyone tell me what do you mean by molar volume? Sir, we know very well about molar mass. Molar mass is defined as the mass of 1 mole of substance in grams. So we are not aware of the molar volume. Molar volume is also related to 1 mole of substance only, but not in terms of mass, but it is in terms of volume. Now I hope you can define the molar volume now. Molar volume is the volume corresponding to 1 mole of entities or 1 mole of substance. Volume occupied by 1 mole of a gas or any gas, let me write any gas at STP, at STP. S refers standard, T refers temperature, and P here pressure. Can anyone tell me what is the value of standard temperature? It is none other than or nothing other than 273 kelvins or 0 degrees Celsius. And in the same way, the pressure which is referred under STP is 1 atm. 1 atm. Right? Is this clear? Fine. Molar volume is the volume occupied by 1 mole of any gas under STP conditions. STP refers standard temperature and pressure. Okay. The molar volume means volume occupied by 1 mole of any gas at STP. Can anyone give me the molar volume? I mean, if you can measure the volume occupied by any gas, 1 mole of any gas at STP, it is equals to 22.4 liters. 22.4 liters, or it can also be written as 22,400 milliliters. Is this point clear? What is the difference between molar mass and molar volume? Molar mass is the mass of 1 mole of substance in grams. So the mass which is corresponding to 1 mole of substance is called as molar mass. In the similar manner, molar volume, we are trying to measure the volume of 1 mole of any gas at STP is called as molar volume. The value of numerical value of molar volume is 22.4 liters, but molar mass is differs from substance to substance. Since the mass of 1 mole of, let's say, hydrogen gas is different from mass of 1 mole corresponding to N2 gas is different. For example, mass corresponding to 1 mole of H2 is 2 grams and mass of 1 mole of N2 is 28 grams. Molar mass may differ from substance to substance, but molar volume is a constant. If you take 1 mole of dunya mein, like if in this world, if you can take any gas, if it is 1 mole, under STP conditions, it will occupy 22.4 liters. Is this point clear? Is this point clear? Why people are not responding? Is it okay? Students, am I audible? Wow. Good. Is this point clear? Fine. Okay. So I wanted to define one more law, or this is important, very important law which we will be studying in future classes also. Avogadro's law. Right? So this states that statement 1 mole of any gas at STP occupies 22.4 liters. This volume which I am referring, 1 mole of any gas, is considered to be molar volume, as I have given already. Molar volume. This particular volume is called as molar volume. Fine. The statement can also be referred in this way. Statement number 2. Statement number 2. Avogadro's law. Equal volumes of gases contains equal number of moles. Contains, let me write few more things. Equal number of moles. Here I wanted to refer under same temperature and pressure. Same temperature and pressure. You can fix, let it be STP or any other. You have to specify a temperature and pressure. If you can specify temperature and pressure, that is at constant temperature and pressure, if the moles of the gases are same, equal moles is equals to equal volumes. It means if the moles of the gases are equal, then volume occupied by the gases are also equal. And then second one I am going to write or equal number of molecules. Equal number of molecules. Or here I wanted to explain one more point here, atomicity, after giving this statement. Let me write fourth one also. It may or may not contains, may or may not be having equal number of atoms. Let's try to understand this statement. Statement 1 I have given, cis to ideal SSS. Yes, we can calculate, real gases deviate from the ideal behavior. Good point. We can calculate the molar volume by considering the gas as ideal gas. So if it is a real gas which exists really on the earth, that condition is different. It deviates from ideal behavior. Those all conditions we will be talking in the future classes. So here our point is to know about the molar volume. Molar volume is the volume occupied by 1 mole of any gas under STP conditions. Okay. So the molar volume can be calculated by taking ideal gas equation. Yes, that is correct. Very good. So if in the case of real gas, it is another story that I am going to deviate in this class. Fine. Now I have given the statement for Avogadro's law. First statement states that 1 mole of any gas at STP occupies 22.4 liters. If you take any gas in this earth, any gas, if it is 1 mole and if you are specifying conditions at STP, it occupies 22.4 liters. This volume is called as molar volume. I have given statement number 2 also. Equal volumes of gases contains. It means when the volumes of gases are equal, if it contains same number of moles. It may also state equal number of molecules also we can contain. I mean equal number of molecules also observed. And here equal number of atoms, I cannot assure you that atoms also are going to be equal. Atoms may be equal or may not be equal. May be equal or may not be equal. Fine. Listen carefully. Here I am going to state here. If number of moles are same, number of moles, if number of moles are equal, consider if moles are equal. If moles are equal, gases, let's say A and B gases, consider 2 gases I have. If moles are equal, what I can say? volumes occupied by gases also equal. Volume occupied by gases are also equal. What is the volume occupied by these two gases? If you specify the condition at STP, by referring STP, if number of moles are equal, then volume occupied by the gas is also equal. Then I can also write number of molecules. Number of molecules are also equal. So same number of molecules. Here I can say number of atoms also can be equal to number of atoms when if the atomicity of the gas, atomicity of gases is equal. If the atomicity is not same, then number of atoms is not equal, right? Students, please try to answer. Now I am going to give a point, a very important point. Now let's conclude this one. Under STP condition, if moles are equal, what are going to be equal? Volume occupied by the gases is equal. Number of molecules of the gases are equal. But number of atoms may or may not be equal. When I can say number of atoms can also be equal, number of atoms will be equal if the atomicity of the gases is equal. So what is atomicity? Let's try to define atomicity. It is a city. Define city. What city we are going to define? Atomicity. Atomicity. Okay. It is the number of atoms. It is the number of atoms present in 1 unit of compound. 1 unit I can say 1 molecule you can take. 1 molecule of compound or 1 formula unit of ionic compound. 1 formula unit. Let's try to write the atomicity for few compounds. Is this point clear? Is this point clear? Students, I was trying to say if the number of moles are equal under STP conditions, before going to discuss these parameters, we have to set the conditions at STP. At STP, if number of moles are equal, volume occupied by the gases will be definitely equal. Number of molecules present in the sample is also equal. Let's say gas A and gas B. Number of moles of gas A and gas B equal. Then volume occupied by gas A, gas B will be equal. Number of molecules present in A will be equal to number of molecules present in B. And number of atoms present in A is equal to number of atoms present in B when if the atomicities of gases are equal. Is this point clear? I am going to give an example. Try to give the answers. Be ready with your answers. Shall we start? Right, I am going to give a question. Please try to give the answer for this question. Okay, I have gases. Let's say I have N2 gas. N2 gas, 1 mole I have taken. And O2 gas I have taken 1 mole. And I have taken even H2 gas. I have taken 1 mole of each H2 gas. Before this, I wanted to specify conditions at STP. I have 1 mole of N2 gas and 1 mole of O2 gas and 1 mole of H2 gas. Okay. Now, under STP conditions, what could be equal? If I am right, please correct the statement. If it is correct or wrong. Statement number 1. Nowadays, in the NEET examination, they are actually giving questions in this way. They are giving 4 statements, asking us to find how many of these statements are correct. Even sometimes you may get, if you are lucky, 6 statements also you may get. Fine. So here I am trying to say, Mole I have specified already. All gases have same moles. If the moles are same number of moles already. This point was given. Then what could be equal? Moles are equal anyway. Second one, same number of these gases contain same number of molecules. Am I right? This statement is right or wrong? Anyone tell me? Next, third statement I am trying to give, same volume occupied by all the gases. All gases occupies same volume. And then the fourth statement is all gases contain same number of, all gases contains same number of atoms. How many of these statements are correct? Statement 1 is given already in the question itself. Yeah. Very good. Same number of moles as I have given already. This is anyway correct statement. And same number of molecules. If moles are same, molecules are also same. If molecules, of course, volume occupied by the gases is also same because moles are same. I can also relate these two. Molecules, volume occupied by the gases is also equal, and all these gases contain same number of atoms. Since atomicity of these gases, let's try to define atomicity. I have given the definition already. We will try to find out atomicities of few molecules here. What is atomicity of N2? Here, just try to tell me atomicity. Here, what is atomicity of N2? Atomicity of N2 I am writing here. What is atomicity of N2? It's 2. Atomicity of O2 again 2. Atomicity of H2, it is exactly 2. What will be the atomicity of CO2? What is the atomicity of CO2? What is the atomicity of CO2? 1 carbon atom and 2 oxygen atoms. In total we have 3. What is atomicity of CH4 molecule? What is atomicity of CH4 molecule? 1 plus 4, that is equals to 5. What is atomicity of NH3 molecule? I think I have 4 atoms here. What is atomicity of H2SO4? Can anyone tell me atomicity of H2SO4? Dear students, try to give the answers. Don't be diverted with anything. So please pay attention and respond to the answer and listen properly. Follow the class properly. Okay, when you are having free time, you can have chit chat with your friends. You can talk through your phone. So when you are physically sitting in the class, I'll encourage you, or I'll request you guys to focus on the class, so that you will not miss anything which is explained in the class. Very good. So 7. Very nice. I have given one more molecule, C6H12O6. Write the atomicity over here. Atomicity. Next, try to write the atomicity of atomicity. What is atomicity of? I think you know very well about this compound. This is glucose, C6H12O6, and this is sucrose, or it can also be referred as cane sugar. Very important. Very good. 6 plus 12, 18, 24. Very nice. Superb. And what is atomicity of sucrose? Sucrose atomicity of sucrose 45. Good. Very nice. So atomicity. Now I can say atomicity of N2, O2 and H2 are equal. Hence I can expect the number of atoms also would be equal in the given sample. Right? Students, one more question I wanted to specify. One more question I am going to give. I have the sample of helium at STP. Before writing this, at STP, specifying the conditions, I have specified the conditions. Now I have He, and I have, let's say, CH4 gas, methane. I think you know very well about this gas, methane, methane, and I have, let's say, NH3 gas, NH3 gas. So, my dear students, now I want, let me write one more, Cl2 gas. Okay. Now, my dear students, your here given parameter is, I have given mole of He is 1 mole and methane moles also I have specified here, and ammonia moles also specified here, and Cl2 moles also specified here. Now, dear students, now tell me, I think you know about this helium. This name of this element is helium. This is methane, and this is ammonia, ammonia gas. Now, tell me first point. I have given moles as same: 1 mole, 1 mole, 1 mole, and 1 mole. Well, okay, okay, very nice. Now, second point. Volume occupied by these gases. Tell me, students, how much is the volume occupied by these gases at STP? I have specified the conditions. I have specified the conditions here. Under STP conditions, I have given moles of all the gases as 1. Why are noble gas atoms considered one atom? Yes, yes, very good question. Noble gases atoms are the only atoms which have independent existence. Atoms of all other elements do not have any independent existence. They do exist in molecule form. Okay, Sis2, Navdeep, actually noble gases are considered to be stable atoms because of their octet. Of course, if you take helium, it has 2 electrons in its valence shell, that is called as doublet configuration. The remaining all elements are having 8 electrons in their valence shell. They are satisfying octet. They are comfortable, bindas. They are stable. So they try to exist in the atomic form. Except the noble gases atom, remaining atoms of all other elements do not exist independently. Okay. They'll try to combine with some other atoms and try to be in the either molecular form or in the compound form to achieve their stability. Is this point clear? Now tell me, what is volume occupied by helium at STP? 22.4 liters. What is the volume occupied by methane gas at STP? Again 22.4 liters. And what is the volume occupied by ammonia gas at STP? It is again 22.4 liters. And what is the volume occupied by Cl2 gas at STP? Exactly 22.4 liters. Why all of 22 points? Yes, very good. Actually 22.4 is more accurate compared to 22.4. So for simplified calculations, we prefer to use 22.4. Saroja, Goody Party. Yes, very good point, valid point. So we will be talking about all these parameters. Actually, I'll try to calculate and show you what is exact value and why we are using 22.4. So to be more accurate, we prefer to take 22.7, but for the sake of convenience, for simplified values, we'll take 22.4. I'll show you how the value was obtained. Don't worry. Good. Okay, now tell me, my dear students, how many molecules are present in 1 mole of helium? How many molecules are present in 1 mole of helium? Try to answer, please. How many molecules are present in 1 mole of helium? Exactly 1 mole only. That is Avogadro number. Na, I have referred with Na. How many molecules are present in even 1 mole of methane? Again 22. Avogadro number of molecules. Even in ammonia also we have Avogadro's number of molecules, and even Cl2 also same number of molecules. As we have concluded that if the moles are same, then the number of molecules will also be same. Now, my dear students, fourth statement is very important for me. Fourth statement, try to answer fourth statement. Do all of these gases contain same number of atoms? Do all of these gases contain same number of atoms? Is this statement correct? It is a wrong statement. These do not contain same number of atoms because atomicity of all these gases is different. So number of atoms present in a given sample of a gas at STP is not decided by number of moles alone. It may not be necessarily equal. if number of moles of the gases are same, volume occupied by gases can be same, definitely will be same. Number of molecules present in the 1 mole of sample also exactly same, but number of atoms present in given sample of gas at STP is not necessarily equal. It all depends on its atomicity. Okay, here atomicity of helium is actually 1. Therefore, number of atoms, if I refer number of atoms, here I will try to write molecules, here volume, and here moles, and let me write here atoms. Yes, tell me. So here number of atoms, if I refer how many atoms are present, exactly Na atoms, since atomicity of helium is 1. Here what is the total number of atoms present in 1 mole of methane? Atomicity of methane is 5, therefore it contains 5 Na atoms. Atomicity of ammonia is 4. Hence, the number of atoms present in 1 mole of ammonia is 4Na, and number of atoms present in 1 mole of chlorine is 2Na. Is this point clear? It is very interesting point. It is very important. In fact, it was given for NEET exam, previous NEET exam. My dear students, I am going to encourage you. If you are able to answer the question which was given for previous NEET exam. Okay, this is very important point. The fourth statement is super very important point. I hope these points are very clear. Okay, shall we conclude the Avogadro's law? Okay, so Avogadro's law states that if moles are fixed, volume will be fixed, molecules will be fixed, but atoms are not fixed, provided if you are taking all the gases at STP. Okay, number of atoms present in given sample of gas at STP is decided by its atomicity. Yeah, it is PYQ of NEET only, Prakash. So you have answered already. See, you guys are able to answer the NEET previous year questions also. Okay, so my dear students, people who have followed, I think you have gone through the like shorts which were there in Sri Chaitanya Gosala YouTube channel. So our students who are studying now in 12th standard, so when we are moving from their 10th to 11th, they have taken bridge course. I think they have given testimonials about the bridge course. So how much useful actually they have learned in the bridge course. So the bridge course was very useful for them, and if you can follow properly the bridge course which you are taking now, take it as very seriously and follow the classes properly. This will be really very important. I mean encouraged with this statement also. So students who have not taken the foundation courses, no worries, don't worry. If you can cope up, if you can follow the bridge course which we are giving during these days, if you can follow, you will learn all the basic foundation courses during the days or upcoming days. During already we have completed few days and few more classes we will be taking. So you will definitely crack the NEET examination with proper marks, with a very good rank. Okay, fine. So this is about Avogadro's law. Now let me summarize the calculation of moles with this diagram. Calculation of number of moles. Number of moles. Fine. Good. Dear student, let me place the mole over here in the exactly. Okay. Fine. Now here I am going to write mass over here. Yesterday I have given already mole in terms of mass and mole in terms of number also I have given. Mole in terms of number. I am going to add one more now. Mole in terms of volume at STP. Whenever we are specifying volume, it should be specified the conditions at STP. At STP. Mole. Okay, volume at STP. Now, how to convert the given mass into mole? Can anyone please? How to convert the mass into moles, or how to calculate if the mass is given? It should be divided with molar mass. So mass upon molar mass gives the mole. Then if I know the moles, how to convert back into mass? Like we can convert mass into mole and mole into mass, etc. So you should multiply with molar mass. With this diagram, you can calculate the moles for any given substance, with any kind of question. Okay, as I have given already, how to convert the given number of particles into moles. How to convert the given number of particles into mole? If you can divide with Avogadro's number. So given number of particles upon Avogadro number is equals to mole. Then how to convert the moles into number of particles? I mean to say, if the number of moles are given, how to convert them into number of particles, or how to convert given number of moles into number of particles? Let's say 1 mole of substance Avogadro number, 2 moles of substance 2 times that of Avogadro number. Yeah, Navdeep, excuse me, I have a doubt. What about case of allotrope? How does the atomicity change between different allotropes of the same element? Yeah, atomicity is same only, because what is difference there? What is difference there? For example, if you take isotopes of carbon, okay, atomic number is same, mass number is different. So if I am trying to measure the molar mass, their molar mass will be different. Okay, what makes the difference in isotope? If I am trying to calculate the number of moles of given isotope, okay, when I am trying to calculate number of moles, mass will be given, mass upon molar mass. There the difference parameter is molar mass. If the molar mass is changing, then moles also will be going to be changing. Fine? Good. Okay, I hope this point is clear. Nice. Now, how to convert the given volume of substance at STP into mole? I can convert the volume into mole by dividing with the molar volume 22.4. Then how to convert the mole into volume? If the moles of a substance or gas at STP is given, we can calculate the volume just by multiplying with 22.4. This is considered to be Y map kind of thing, by using which we can calculate the moles into mass or mass into moles, number into moles, and moles into number, vice versa. Fine. Okay. So please try to have an idea about this Y map. Try to have an idea about this Y map. Okay. With this, I'll try to close this one, calculation of number of moles. Let me take an example and we'll try to illustrate few calculations. Okay. From here onwards, mass in grams by mole. Yes, very good, very good, very good, very good. So here many of you guys are giving proper answers. Okay, good, good, good. If you have completed this, then shall we move on to the example question number 1? Be ready with your answers. Question number 1. After this, I'll give some important formulae to find out quick calculations. I have given 1 mole of water. My dear students, 1 mole of water. Let's try to illustrate 1 mole of water. If you want me to write at STP also, I'll specify at STP. Let us consider this as vapor or in gas state, let's say. So in order to even specify the volume also. Okay, okay. Tell me, 1 mole of H2O at STP contains will be equal. Molar mass, tell me first. Contains how much mass? I need mass. 1 mole of H2O contains 18 grams of water. Am I right? 18 grams of water. 18 grams is the molar mass of water. Since I have given 1 mole, 1 mole of any substance, 1 mole of mass corresponding to 1 mole of substance is called as molar mass. What is molar mass of water? Molar mass of water. Molar mass means we need to specify the mass in grams. This can also be referred as gram molecular mass, GMM. Yes, tell me, 2 times that of 1 plus 16 equal to 18 grams. X 1 mole. So 1 mole of H2O is totally weighing 18 grams. Next, how much is the molecule volume occupied by 1 mole of H2O at STP? 22.4 liters. Yes, I can say. I can say. Next, how many molecules are present in 1 mole of H2O? It is exactly Na number of molecules are present. How many atoms are present in 1 mole of H2O? How many atoms are present in 1 mole of H2O? GMM, gram molecular mass, you can say, or you can also refer collectively as molar mass. Molar mass. You can also refer it collectively as molar mass. Okay. How many atoms are present in 1 mole of H2O? How many atoms are present in 1 mole of H2O? Atomicity of H2O is actually 3, and it should be multiplied with Avogadro's number. Hence, the total number of atoms present in 1 mole of water is 3Na. And how many total number of electrons are present in 1 mole of H2O? So before that, calculate the total number of electrons present in H2O single molecule. One molecule of water contains in total of 10 electrons. How I got this value? As you know already, hydrogen atomic number is 1 and it contains 1 electron. 2 hydrogens we have, 2 times that of 1, so 2 electrons. And oxygen atomic number is 8 and it contains 8 electrons. So altogether, total number of electrons present in single molecule of water is 10. Now we have 3 times that of Avogadro number of molecules we have. If each molecule contains 10 electrons, 3 Na molecules contains 3 Na times that of 10. Therefore, total number of electrons present in 1 mole of water is 30 Na. I hope all these points are clear. So with this, I wanted to stop for today's session. Students, if you feel like this video is helpful to you, so please try to subscribe the channel first if you have not subscribed, and please and forward the classes for your near and dear friends so that those people also can be benefited. So with this, I wanted to stop today's class. If you like the session, please forward your friends also. So thank you, and that's all. Have a nice day. Okay, sir. అయిపోయాయి సార్ రిచువల్స్ ఊరిలో